Okay guys, you're welcome back to Speed Math with Promise. Today's video we're going to be looking at Math 206. Okay, now we're going to be solving series of questions for our test, CBT test to be precise. So the first question goes to us: Z bar Z is the same as what exactly? So I'm not going to be wasting time on them. I'm not going to be proving them to the from the beginning to the end. So now we all know that Z bar, or first of all, to start with, Z is an expression of complex number x plus iy, right? So since it is so, z bar, which is the conjugate of this, will now be x minus iy. So by the time you multiply this, multiplying the both of them, now what we should get is x squared plus y squared. Okay, so that's exactly what we should get, and this is the same thing as the absolute value of z all squared. Okay, now that is it has been proven. So if you are given this question, the same thing, whatever it is, if you're asked to find what is exactly the same as z bar multiplied by z, is actually absolute value of z all squared. Now moving to the next one, we have to find the absolute value of z1 plus z2. Is it less than or what, or equal to the absolute value of z1 plus the absolute value of z2? Now this is not equal to this exactly, but it is less than or equal to it. Now when they say less than or equal to, that means it's somehow equal to this. Okay, it's just like someone saying, let's say for instance, now if z1 was going to be 2 and z2 was going to be what, let's say 3 for instance, the absolute value, I just want to prove to us that it is actually true, that this is what. So the absolute value of z1 plus z2 will be what, 2 plus what, 3. Okay, and if you do likewise, we are going to, you see that it's going to be equal to the absolute value of what, z1, which is the absolute value of 2 plus the absolute value of what, 3. But what if this becomes minus 3? Okay, what if this becomes minus 3? Let's say you have z2 to be what, minus 3. So in this situation, they are not going to be equal. So it is true that the absolute value of z1 plus z2 is less than or equal to the absolute value of what, z1 plus the absolute value of z2. So I wouldn't want to prove this too much, so it is very true. So moving to the next question, remember this is CBT test and you wouldn't want to waste too much time. Okay, now how do we solve this in seconds? So in order for you to solve this, just concentrate on it this way. Make sure that the real part and the imaginary part are separated from each other. So this will now be the absolute value of what, of the real part, e to the power of real part, multiplied by the absolute value of e to the power of the imaginary part. By so doing, you will now tell yourself that for the real part, it's still going to be the same thing, right? I mean, when I mean the real part, talking about the exponent. So but for the imaginary part, anytime you see the absolute value of e to the power of imaginary, just know that it is 1. So by the time you multiply this, you get e to the power of 2a, and that's your answer. So moving on to the next thing, so I want us to be very fast. So they ask us to find the modulus and arguments of this complex number, and the complex number that we're giving is minus root 3 plus I. If I was to draw the Argand diagram of this, remember this is x, this is y, okay, according to x plus iy. So this is the positive x-axis, this is the negative, positive y-axis, negative y-axis, negative x-axis, positive what, x-axis. So in this case, this is what, negative of x-axis and positive of y-axis. So negative of x-axis and positive, so it's going to be along this. Okay, so along this side we have our minus what, root 3, and here we have our I. So in that case, it's going to be along this what, quadrant, which is the second quadrant. With that being said, let us find our modulus. What is our modulus? It can be gotten as a result of what, the square root of, some people call it the absolute value of z, or you can call it r. Okay, I don't know if we are seeing this. So it's the what, the square of what, minus root 3 plus what, the square of what, the square of the real part and also the square of the imaginary part. So with that being said, is the square root of, square will cancel square roots, and of course minus squared is going to give you positive. So we have 3 plus 1, and the square root of what, 4 is 2. So remember the same modulus and argument respectively. So we have our 2 to be our what, modulus. Then for our argument theta, which is literally the tan inverse of what, of the imaginary part. What's the imaginary part? We have it, the coefficient is 1, and that of the real part is minus root what? 3. Okay, so with that being said, we know that the tan inverse of this is actually what? Minus 30 degrees. But in terms of pi, we just have to multiply pi over 180. Okay, so by so doing, when you reduce this to the lowest, then you get minus pi over 6. Now, we can actually make this a principal argument. On this axis, to get the principal argument, is going to be pi minus what? Theta. Okay, so as we have gotten this now, we'll now say pi minus, forget about the minus here, just take pi over 6. So pi over 6. So by so doing, we'll have 6 pi. This is how to do it fast. Cross this, 6 times pi, 6 pi minus pi over 6, which is 5 pi over 6. So this and this are the same. Okay, so let us say 5 pi over what? 6. Now moving on to the next question. I want us to be very, very fast. Okay, we have a lot of questions to solve because we have tests soon. So what is the cube root of this function of a complex number? So they give us z to be what? 1 plus I, right? So they're asking us to find z to the power of 1 over 3. So how do we do that? So we are going to be applying our De Moivre's theorem. Okay, so and what do we do to get this straight? You just say z, which is equals to your modulus. First, let's find our modulus. What is our modulus? From here we can see that our modulus, just like what we did here, the square of this plus the square of this, which is what? 2, right? The square of this is 1. That is 1 squared is 1. The square of 1, that is 1. 1 plus 1, 2. So root what? 2. Just like what we did here. So now our argument from here, if you observe closely, is going to be the tan inverse of 1 from the imaginary part over 1 from the real part, which is what? 45 degrees. Okay, and you just attach pi to it, 45 pi over 180. And I believe we know what 45 pi over 180 is. So 45 pi over 180 is what? Pi over 4. So this is our argument. So I just have to do it here because I need us to use the other space. Okay, so now how do we get this done? First thing you need to know is what? You first write your argument, your modulus. What's this modulus? The modulus is what? Root 2. But let us write it in terms of what? In terms of indices, or in index form. That is the same thing as 2 to the power of 1 over 2. Right? So let me bring this down. So our z will now be the modulus, which is 2 to the power of 1 over 2. Now, since you are looking for cube root, you multiply by 1 over 3. Right? Then you say cos. Now, don't forget that you are dealing with 1 over 3. So cos, first of all, you write your 1 over 3, then multiply by, what did you get here? Pi over 4. Write your pi over 4, then plus I sine. You do likewise. Okay, so you will say 1 over 3, which is the cube root, multiplied by pi over what? 4. Okay, so by so doing, our final answer is 2 to the power of 1 over 6 into cos what? Cos pi over 12 plus I sine what? Sine pi over what? 12. Now, sometimes we can get to add plus 2 pi k. Okay, for this particular one, our k, they normally write z subscript k. Our k is 0. Okay, our k is what? 0. So the reason I'm saying this is the argument sometimes we can actually add 2 pi what? K, where k can be 1, 2, or 3. Okay, so now depending on how the question is, if they ask you to make k to be 1, that means you're adding 2 pi to it, so you can't add 2 pi here. But that's by the way. So let's move to the next question. We have a lot of questions, over 20 questions to solve. Now, how do we solve this particular question? We were asked to find limit as z tends to minus I rather. So how do we get this done? Now, if you observe, this could not be literally done easily because this there's a discontinuity in this case, so we need to remove the discontinuity. So there's a discontinuity as a result of the numerator. So z squared plus 1 over z plus I, right? Now, for In that case, to remove the discontinuity, we say z squared is z and z. Definitely, anytime we are writing something like this, there will be a plus and there will be a minus. Okay, so in that case, to get one, I normally we know that I times I is minus 1. So the fact that you have minus 1 as I times I and plus times minus is minus, minus times minus will now give you what? Plus. Okay, so this is how this should be expanded. So the denominator will now have z plus what? I. And if you look at it, this will cancel this. So what you have been able to remove the discontinuity. Okay, so please, this is 0. So remember, they say we should make z to be what? I. So it becomes I. Show this question. This question is looking incorrect. Okay, so now this is actually minus rather. So in that case, it becomes minus I, right? Minus what? I. That will now become minus 2I, and this is our answer. Now moving on. So how do we do this? For you to be able to do this, you need to what? Differentiate. And when we want to differentiate, according to our quotient rule in differentiation, whenever we have one thing over the other, so let's differentiate this. So we'll say f prime of z, meaning first derivative of this. Now first, you have to what? Keep this z plus I, right? Then you differentiate this. If you differentiate this, you get 2z. Okay, now when you differentiate this, you get 2z. So minus, remember it's quotient rule, we are differentiating using what? Quotient rule. So by the time you now you are going to keep this one. Remember, it was this one you kept initially. So you are going to keep this one z squared minus 1. Then you differentiate this, you get what? 1, because you are doing everything with respect to what? Z. You are paying respect to z. So all over the down one squared, z plus I, all what? Squared. So let's do this now. So let us expanding this now, or let us substitute. So anyway we see z, please, this is f of z, so it simply means we are going to substitute. Anyway we see z, we put I. So let us do that straight up because of time. I don't want this video to be too long. So we have I plus I, right? Then multiply by 2I, okay, minus I squared minus 1 multiply by what? 1. All right, so all over I plus I, all what? Squared, right? Okay, so in this case, let's continue. So with that being said, I plus I is 2I. 2I plus 2I, this is 2I multiplied by what? 2I rather. So minus I squared, we all know that I squared is minus 1, so minus 1 multiplied by 1 is still 1, all over what we have here is 2I, right? So 2I all what? Squared. So in this case, 2 times 2 we know is 4. I times I we know is minus 1, right? Remember I told us from here that I times I is what? Minus 1. So put minus 1 here. Minus 1 minus 1 is actually minus 2, right? All over 2 squared we know is 4, and then I squared, because you are going to do each of them squared, is what? Minus 1. So with that being squared, our final answer is 4 times minus 1 is minus 4, right? And then plus minus times minus is plus, so plus 2 all over minus 4, right? Because this will give us minus 4. So minus 4 plus 2, that's minus 2 divided by minus 4. So in that case, if you divide this, you get 1 over 2, right? So I hope we are seeing this. So let's continue. Now we are in the sixth question. We still have more questions to go. Now we are asked to find the principal value of this. This is very simple. So the solution to this is, first you find your modulus. I've told you guys how you call it the absolute value of z, or what? Or r, right? Is equals to the square root of. Now this side square, that's root 3 all squared plus minus the coefficient of this is what? 1, so minus 1 all squared. Now definitely when you find root 3 all squared, square will cancel square root, so you have 3 plus 1 squared is still 1, So that's going to be square root of 4, which is what? 2. So we have gotten this. So you get your what? Your argument, which when you look at this, your argument is going to be the tan inverse of. Now always remember the imaginary part minus 1 over what? The real part. Always know that whenever you have 1 over root 3, just know that it is 30. So because of this, you have minus. So attach pi over 180 here. So this will now become minus pi over what? Over 6 when you reduce this to its lowest term. So that means the principal value will now be log of, first of all, you have to write your what? Your modulus, which is 2, then plus what? Plus your what? I, and then your argument, which is what? Pi over 6. So this is your principal value. So moving on, let's get things done. So how do we get this done? So just like we did for the previous one, which was question 4, right? We did something for question 4 here. So that's exactly the same thing that we're going to do for this question. So in this case, let's continue. Now, what are we supposed to do? We're going to remove discontinuity. If you observe, it's going to be from the one in the denominator. Let us what? Remove the what? The discontinuity for the one in the denominator. So how do we do that? So this is now going to be z plus I. Okay, this is my z. Please, it's looking like 2, but then it's z. So if removing this now, you have two parentheses where you have z plus I, z plus 1 rather. No, z plus I and z minus what? I. Okay, because minus I times plus I will give you plus 1. So this we cancel what? This. So you now have 1 over z minus I. So remember they say anywhere we see what? I, we should put minus 1. So that was going to be 1 over, what is our z? Our z is what? Minus 1, because they say limit as what? Z tends to what? Minus 1. So that becomes minus 1, minus 1, minus I rather, minus I, minus I. Okay, so minus I, so that becomes 1 over minus 2 I, and that is our answer. So let's move to other question. So question number 7 is done. So let's move to question number 8. Now for question number 8, how do we solve this? So we have to simplify this. So this can be simplified either in Euler's form or what, or in other form like the polar form. Okay, for the Euler's form, where we have the z to be what? R to the power of n. Remember, using de Moivre's theorem. I'm going to be explaining de Moivre's theorem soon. De Moivre's theorem. So then we now have e, right? E, then where we have n, in theta. Okay, so anywhere you see your n, the n stands for the exponent that you are seeing there. Okay, but then we have 2 there. We have n, let's say this is n1 200, and then we have n2 to be what? 160. Okay, so with that being said, let's first of all find our modulus. Our modulus from here, for the r, let's call this 1. We have 2 complex number here. We have z1 and z2. Okay, so for the z1, let's find the modulus for the z1. So in this case, how do we find the modulus for the z1? Is the square root of, square of 1 is 1, square of what? 1 from this I is 1. So the modulus is what? Root what? 2, which is 2 to the power of what? Half. Now the same thing for the second one. Let's find the modulus. The same thing, I think 1 squared plus minus 1 what? Squared. Okay, so 1 squared, remember 1 squared plus minus 1 what? Squared from here. So in that case, it becomes what? The same root 2, which is 2 to the power of 1 over 2. So the fact that you're going to look for simplify this now, we still need to find our argument. From here, we've done something like this before. The argument here is pi over 4. Okay, for both of them, pi over what? 4. But then this one, due to the fact that there's minus, it will be minus pi over 4. So for the theta 1, which is from the first complex number above, it is pi over 4. For the down one, minus pi over what? Over 4. Okay, now in this case, just keep it down. So in this case, let us find our z. So this time, remember, we have 2 z. That will be z1 divided by what? Z2, right? So it's more or less like saying R1 divided by R2 first. So that's what I just want to do this. This will now be, since the both of them are having the same thing, we'll remember the law of indices, right? So that will be 2 to the power of, since the both of them are having the same thing, we'll say 2 to the power of half, right? Minus what? Half. Yes. The reason for this is because we we the reason for this actually is because of the fact that we are dividing one by the other. Okay, so since we are dividing one by the other, this is what is going to be. But remember, even as we are doing this, we should take note of what the argument, the n. What is our n? Our n for this one is 200. So what we are going to do is, let us do it one after the other. So we'll say, let's put it this way: 2 to the power of half of 200 for the first one, all over. Let's just do it straight. Let's just do it like this first. Half of what? 160. Okay, remember we are going to be attaching n to it. Please, this is what we are following. Okay, but since we are dividing one by the other, we have to do this. So now multiply by the up one, we have its own e, the down one we have its own e. So this one we have its own e, right? Remember we say it's I n theta. So I first, what's our n? 200, right? Then multiply by what's our theta? That's theta 1 for the up one is pi over 4. Then divided by, we do likewise for this down one, I 160 multiply by what? Pi over what? 4. But it is going to be minus pi over 4. Okay, so in that case, combining these two things, we can use indices here. That thing I wanted to do initially too. From here, what we now have is what we actually have from there is what? 100. Okay, so we have 100, but because of the fact that we are dividing, we are going to now minus. What do we have here? 160 divided by 2, we have what? 80. Now we have e here, we just take one e, right? For this one, 4 can divide 250, right? So put our I. So we have 50 pi here. Here 4 can divide 160. Don't forget we have minus. 4 can divide 160 what? 40, right? So in that case, pi is common, right? Since pi is common, I'll write my pi. Then don't forget I have 50 here, so 50, and I have 40 here, and I have minus. But due to the fact we have division, minus minus become plus 40. So this is your final answer. We have 2 to the power 100 minus um 80 is what? 20, right? And then e to the power of what? I pi. What do we have here? We have what? We have 90 here. So this would have been the final answer. But you know that all of this should give us 1 actually. That's the reason. That's my emphasis. So what only thing we have is 2 to the power of 20. Now the reason is this. I'm using Euler's form. I didn't mean I used how do I explain this now? I didn't mean I used polar form. I mean I used the polar form. I would have compared it such that I will do cos 16,000, like cos pi 90, and what? Sin pi 90. So in that case, one of them will give me 0, the other will give me 1, thereby making everything to be what? 2 to the power of 20. So since I use the Euler form, it's not going to be easily what? Gotten. So have it in mind that e to the power of I pi 90 is what? 1. So that's by the way. So let's move to the next one. So how do we do the next one now? Is how do we solve this? Or we're asked to actually check this out. Now how do we actually solve this to know where it's to know whether it is converging or diverging and stuff like that? So in order for us to do this, what we are going to do is, okay, I just want to time, we are almost, this 25 minutes of the time, so I need us to finish this up on time. So what we are going to do is, let us expand this from here. So if you expand this, what you are going to have, this and this will give you all to the, I will just put all of them together. That will be n, right? N squared plus n, right? If I multiply this by this, I want to expand this bracket, then minus root n times root n will give you n. Now, in order for us to remove whatever discontinuity that is here, we must what? Rationalize. Rationalizing this is more or less like saying root n squared plus n. Since we have to do the conjugate of this, meaning plus n, right? Exactly. All over root n squared plus n plus what? N, right? So by so doing, we can actually, now anytime you have exactly the same thing here, you want to expand, it's as simple as saying this and this, first and last. Okay, if I do first and first, this the I will just have to what? Pick what is inside. Okay, you just like your sword, root 2 times root 2 is 2, so I will just pick what is n squared plus n, right? Now if I do last and last, minus times plus is minus, n times n is n squared, all over root n squared plus 1 n plus n. Now if you observe, n squared minus n squared, we what? We cancel. You just have n over uh square root of n squared plus n, right? Then plus n, isn't it? So by so doing, I want to extend this such that, remember, this is limit. This is actually what? Limit. I forgot to say this. Limit as what? As n tends to what? Infinity. Okay, of whatever all these function. So I want to do this such that I will introduce square root up and down. Or let us look at it. Let's say this is n, right? Okay, I know if I say the square root of n, I'm looking at the highest powers. If I look at the square root of n now, this is another n here, right? I'm going to consider that since I'm considering this n. And if I say the square root of n squared is definitely going to just be what? N, uh n. The square root of n squared is definitely going to be n. So this is going to be n over what? 2n. And by so doing, we have 1 over 2, and that's our answer. So let's get this done now. Now mind you, this is just this one is square root of n, so that one is already gone. That one's going to be very, very small. So square root of n squared, concentrate on the highest power, and then this. And since you are concentrating on this, you should also consider what? This. Okay, with that being said, let's do this one now. So in this case, let's look at this. This is a function, and they ask us, is this an entire function? When they mean entire function, does it that is it going to be analytic? That's what they are trying to say. Being an entire function, it has to be what? Analytic, or it has to be an analytic what? Function. So from the look of things, when you say modulus of z square, first of all, modulus of z, we say it, we know it as what? S squared, square root of what? S squared plus what? Y squared. For those of you that follow this video from the beginning. Now, and then you now said all what? Squared, meaning square we cancel square root, meaning you just have s squared plus y squared left. Now if you observe, we only have but what? The real part. We don't have the imaginary part, which is the neighboring part. Since we don't have the neighboring part, which is the imaginary part, this is not analytic. So hence, this is not what? Analytic, and it is not entire what? An entire function of a complex number z, because the complex number z has what? The real part plus what? The imaginary part. So this is not analytic, and that answers the question. Okay, so it is not what? Not analytic. We cannot analyze this because this is not a complex number as it claims it was supposed to be. Now let's look at this. Now in this case, this one, they ask us to actually what? Find the imaginary part. I'm doing this not just for the test, okay, the CBT test. I'm also doing it with respect to the exam. So let's see how to find the what. They say we should they say if this is what is an imaginary part of an analytic function, you can see that they give us the imaginary part. Hence, it will what? Satisfy what equation exactly? Now it will satisfy an equation that is known as, it must satisfy Laplace equation. Yes, it must satisfy what? Laplace what? Equation. Now the reason for that is, it must what? Actually satisfy Laplace equation. Don't move in the camera, don't be moving it. So this must what? Satisfy what? Laplace what? Equation. Just hold it. So now what do I mean by that? Laplace equation is vxx, okay, plus what? Vyy is equals to 0. What this simply means is, this particular function you see, by the time we define the derivative twice of the derivative with respect to x and y, we must get what? 0. Okay, right? So that is what would make it to what? So let us see what if that is true. actually. So let us see. In that case, if we do this, we have v to be what? 2x y plus 1, right? So vx, first of all, is what? If you differentiate paying attention to x, you have 1. So you have what? 2y, and this is what? Constant. Then vxx. So since there's no x in here, because it's from here you differentiate again, okay? Since there's no x here again, what you are seeing is y is 0. Now, if you do likewise for what? Vyy, first let's do for vy. From this same function, vy, we'll have 2x plus just 2x. Then vyy, we'll have what? 0, because there's no y here. Remember, you're paying attention, you're paying respect to what? X. And since there's no what? So you're paying respect to y. So since there's no y, is 0. So you can see that 0 plus 0 as vxx and vyy represent is what? 0. So you can see that it actually satisfies what? Laplace equation. Okay, this is with respect to what they are just speaking on, what? On the imaginary part alone. So let's move to other things. But what should satisfy analytic function as a analytic function is the function that that there's a real part, there's imaginary part. Okay, so the relationship between the real part and the imaginary part. Okay, what should satisfy analytic function is what? Cauchy-Riemann's what? Cauchy-Riemann's equation. Cauchy-Riemann's what? Equation. Okay, now what do I mean by Cauchy-Riemann's equation? It's an equation that when you find the partial derivative, now the u part, there will be a function of u part, which is the real part, and what? Imaginary part. Okay, for the real part, by the time you differentiate partially with respect to x, it must be equal when you come to the imaginary part. This is the real part. You do with respect to x for the real part, it must be equal to that of the imaginary part with respect to what? Y. Partial derivative of the real part, they will give you a function of a complex number, complete one, having real part and imaginary part. So that's why I say that this is not analytic, because the only thing we are seeing here is the real part of this function. There's no imaginary part. So this is what actually satisfies what? An analytic function. But this now is what why I say that this one satisfy specifically the imaginary part of what? Of the what? Analytic function. Okay, that's what Laplace equation does. And also it can equally satisfy what? The real part of what? Of the analytic function. This one is specific to Laplace equation, is specific to real part and also what? To imaginary part, because the real part and the imaginary part must be harmonic. They must be what? Harmonic. Now that is all for this. Let's move on to the next thing. So question number 12, this thing is becoming too long, but we have to just pay attention. Very important. Question number 12, the principal value of log I is what? Now when they say principal value of log I, what does it simply means? Now what you are seeing here, they gave you, the only thing they give us actually is only I, right? So now if we were to find the principal value, first of all, we know that the function in this case is I, right, plus 0, meaning the real part is 0, whereas the imaginary part is what? Is I, right? If that's the case, our this thing, what's it called, our modulus is going to be square root of just 1 squared plus 0 squared, which is the square root of 1, which is what? 1. Are we seeing that? Now what about the argument? Now if you observe, it's just I. So since it's just I, if I was to draw this on the Argand diagram, I'm looking at what? Just the what? The imaginary part, which is along the what? Along the y-axis. So I'm looking at I here, right? So as I'm looking at I here, that means this is what I'm looking at. So it's on along this part. So since it's along this part and it is I, you can see that it's along what? 90 degree. Are we seeing it together? So since it's 90 degree, this is actually pi over what? Over 2. Okay, so and anytime I want to find principal value, it's just log of what? Log of r plus what? Theta I, or I theta. So this will now become log of what? 1 plus what? Plus I theta. What is our theta? Pi over 2. So I what? Pi over 2. So this is exactly what it is. But then log 1 is what? We all know that log 1 is actually what? Is 0, right? So the only thing we have left now is what? I what pi over 2, and that's our answer. It's as simple as this. So let's move to the next thing. Now let's go to maximum. What is maximum? The maximum is actually what the maximum number you can actually see that is what included in what in a particular uh, set, okay, or number or sequence of number, whatever. So now if you see the maximum of what of x such that it is an element of what of a real number, and also such that we have what ranging from what 1, they say okay less than 1, x is less than 1. When they say x is less than 1, that means definitely starting from something like 0 or any number, not really 0 actually, because real numbers, any number maybe from the negative, but they say real number. And what, and it's also going to be less than what, 3. Now since they ask us to what to determine the maximum is not going to be 3. The maximum is not what is not 3. Somebody will say, but I'm saying 3 here, but they say that it is less than 3. So the maximum is actually going to be less than what, the max is going to be less than what, 3. So we cannot actually tell the maximum. So in this case, since it's less than 3 and we don't know the exact value, we just tell ourselves that it is how will I put it, we just tell ourselves that the maximum is not cannot be what identified, okay, because real numbers and numbers ranges, since it's less than 3, it can be 2 points whatever. So the maximum is what less than what 3 and not what 3, because that is it. So let's look at this. The supremium, there's something called supremium. Supremium is literally or has to do with uh the actually the maximum bound, okay, the maximum bound, that is actually the supremium. So they ask us here, what is the supremium for this, right? Such that n is what is an element of natural number. Natural numbers are numbers that are like all positive numbers, let's put it that way. So since natural numbers are all positive number, what do we do now in this case? We cannot tell ourselves that the supremium of this, because if okay, let us first for check anyway we see n, let us put 1, because natural numbers actually are numbers that are uh these are actually numbers that are all positive numbers. So if you put n to be 1, let us see what it's going to be. It's going to be like 1 to the power of, first for minus is here, so we can actually say, okay, are we together? So let's see, we can actually say 1 over n to the power of n plus 1, right? Which is like saying 1 over 1 to the power of 1 plus 1, and 1 plus 1 is 2. So this is 1 over 1 squared, which is still 1. So which you see that in that case the supremum of this, is actually going to be what? The supremum of this at least is going to be what? 1. Okay, the supremum of this is going to be what? 1, because by the time we substitute 1 here, we are going to get what? We are going to get 1. Okay, if we decide to substitute 2, the supremum, which is like the max, the largest bound, the highest bound, is going to be 1. So the supremum is going to be what? 1, because that's going to be the largest number. Because if we substitute 2 now, why the supremum is going to be 1, why the and if you are asked to find the infimum, the infimum is going to be what? It's going to be uh minus infinity. No, it's going to be infinity. Okay, it's going to be what? Infinity. Or sorry, let's say, sorry, it's going to be 0 rather. It's going to be 0. Why? Because if you keep on adding 2, 3, 4, the number will be decreasing till it ends to what? 0. So the infimum is going to be 0. So moving on. Now, let's look at this. This is 15i. We have a lot to solve. This is 15i. So in that case, the absolute value of z1, z2 is equal to what? What this simply means is this can be the same thing as absolute value of z1 multiplied by the absolute value of z2. There's no two ways about it, because this is multiplication. Okay, this is what? Multiplication. So in that case, the absolute value entails in all of them. So that's all for this. Now let's look at this one. All the values of x are what? Elements of what? Are elements of real numbers. So since they are elements of real numbers, all the values of x, since they are elements of what? Real numbers, then this is what happens. They now told us that such that we have an absolute value of x plus the absolute value of x plus 3 is less than or equal to 5. So first thing I want, you know what, when they say absolute value, you're looking at plus or minus. If they ask you what's the absolute value minus 2, it's actually 2. Okay, so that is it. So let us do the positive of this. We say x plus 3 is less than or equal to 5. So if we do this, we get 2x plus 3, okay, which is less than or equal to 5. Now that means 2x is less than or equal to 5 minus 3, and 2x is less than or equal to what? What do we have here? 2. Divide both sides by 2. Our x is going to be less than or equal to what? 1. Now, since we have, remember, it's absolute value that we have, okay, or modulus. So we are going to do for negative 2. We say negative x, negative x, negative what? 3, right? Is what? Is less than or equal to what? 5. So if we do the, we have negative 2x, right? So we have negative 2x now. It will now, when we move this to the other side, let us do this very fast. We have 5 plus what? Plus 3. So negative 2x. Now the reason for the negative is because you do for positive, you do for negative. All the places they are plus, you change to minus for the absolute value. So if that's the case, we have what? 8 here. If you divide both sides by minus 2, okay, what would you have? You have minus 4. So it's going to be a bound that has to be from what? From negative 4 to what? To 1. So this is going to be the boundary. Sometimes you see it like this: negative 4 is less than or equal to what? To x, which is also less than or equal to what? To 1. So this is exactly what this means. So it is what? Limited to this range. So let's look at the next set of what? The next set of questions. So we're going to be looking at 16, from question 16 down to, okay, let's look at from question 16. Okay, now please let's pay attention because it's getting tougher. They say a sequence, please, this is very important. This is for a CBT. Okay, so a sequence is said to be monotone increasing if a sequence is said to be monotone decreasing if. Now monotone increasing is like when you have a sequence is just like saying 1 2 3. This is what we call monotone what? Increasing. Or what? You can have 1 1 1, okay, provided that it is what? Increasing, or it is not reducing. So what you can use to explain this is a sequence is said to be monotone what? Increasing if the subsequent one, that is the what? The subsequent one, that is the subsequent value, like this. Now you can see that this is greater than this. Just like saying if this was 1 plus 1 is 2, so it must be greater than or equal to what? The previous one. Let's say this is 1, definitely 2 is greater than what? 1, right? 2, anybody agreed with me that 2 is greater than or equal to 1? Yes, we can agree that 2 is greater than or equal to 1. The reason is because if you do not agree with the fact that 2 is equal to 1, at least you can agree with the fact that 2 is what? Greater than 1. So this is what we mean by monotone what? Increasing. Now for monotone decreasing, the same thing. You can have something like 3 2 what? 1. So it is going to be when what? The next one is less than or equal to what? No, it's greater than, sorry, it's greater than or equal to the what? The one before, the first one is greater than or equal to the next one. So it's just as simple as this. So it's like having 3 2 1 0 and so on. Okay, we can agree. I believe you guys can agree with me that 1 is what? 1, like, sorry, 3 from here, from this thing I just wrote here, which is 3 2 1. Can agree with me that 3 is greater than or equal to what? 2. Yes. So moving to this, how do we solve this? To solve this, I think I've been able to solve this before now. So it's just like saying, okay, you take since there is real part separated from the imaginary part, you say the absolute value of the real part multiplied by the absolute value of what? The imaginary part minus 5i. So we already know that whatever this is still going to be 1. So absolute value of this is still e to the power of 2. So we still have our e to the power of 2, and that's the answer. So with that being said, let's move to the next one. You say we should find the limit of this, okay, of L, right? But first of all, let's work on this first. We know that 6n plus, I'm going to solve it straight up. There's no time, and this is getting to an hour already. Plus 8 over what? N plus 2. So how do we solve this? Please pay massive attention. Now, anytime you see this, because of the fact that this is limit, right? Because of the fact that it is what? It is limit, and it is n tending to what? Infinity. Okay, because they told us that it is what an element of what, of natural numbers. Yes, fine and good, is an element of natural numbers. So it is all positive number, like it's just going to what, infinity. Okay, so we should just consider what with the greatest power. So what we have here is actually 6n over what, n. So that will be what, 6. So at least this thing should what, should converge at what, 6. It should converge at what, at 6, this particular limit function. But then what they ask us, they now ask us, and they will ask us to find the smallest value of what. Okay, okay, that's for this. Find the smallest value of n such that we will now have this expression. Okay, we have an expression, and the expression is the absolute value of 6n plus 8 minus l, that's the limit. So, and then n plus what, 2. Oh, sorry, let me write this here. Sorry, let me write it here so that we'll not get confused. So they say absolute value limit as n tends to what, infinity, definitely. Okay, and they ask us to find the absolute value of what, 6n plus 8 over what, n plus 2, right? Then they now said minus what, l. So they told us that let this be what, less than 1 over what, 10, right? So how do we do this? So I think we've been able to what, resolve from here, right? We will resolve from here from the beginning. So it's 6n over n. So we can now say, and look at what we are looking for, l. So that means from here, what we are literally having here, okay, what we have here as our limit, remember the limit that we got from the beginning is 6. So we can now say that this will now be what, 6n plus 8. Okay, we're actually looking for the value of n over what, n plus 2, right? Minus the limit we got was 6, right? Less than what, 1 over 10. So by the time we do this, we can what, cross multiply. If we cross multiply this, what are we going to get? We get 6n, 6n, right, plus 8 minus, we cross multiply this is a fraction actually, but to make it more easier, 6n, 6 times n, 6n, then plus 6 times minus 2, that's what, minus what, 12. They said that everything here is less than what, 1 over what, 10. Okay, so with that being said, let me solve it further from here. Now 6n minus 6n we cancel, yes, right? Then what we have here is 8 minus what, 8 plus 8 minus 12. So we have 8 minus 12 is less than 1 over 10. What is 8 minus 12? Minus what? Minus 4. Minus 4 is less than 1 over 10, right? So since minus 4, okay, let me check this out. Okay, since minus 4 is what? Is less than what? 1 over 10. Okay, I think we are mixing something up here. Remember, we are looking for the value of n, right? So okay, let us continue. This will now be, when you cross multiply this, you should get what, you get minus 40 is less than what, 1. Okay, now I think I've actually made mistake here. Okay, we'll come back to this. Let's go to this now. De Moivre's theorem. What is De Moivre's theorem? De Moivre's theorem is a theorem that is actually explaining what, the Euler's form and what, and the polar form strictly of what, of a complex number. You have a complex number, z is equals to x plus iy. The Euler form is z is equals to r e theta what, I. Now, if you want to talk about the De Moivre's theorem, it simply means when they ask you to find exponent of what, of a complex function or complex number, exponent. Yes, that's the key thing there, is what, exponent, right? So if that's the case, if you have to find all of this to the power of n, definitely what you have here is n, right? That is z to the power of 10 n will now be n, and also n theta. We can also have z to the power of 1 over n. It will also be r to the power of 1 over n, right? E to the power of what? 1 over n theta what, I. Okay, I want to make sure I explain this very fast. Okay, now this can also be equal to, if you want to write it in what, in polar form, to be r to the power of n. This will still be the same, but it will have cos of what, n what, theta plus I what, sine theta, okay, to the power of n theta. So for this one, it will be what? R to the power of 1 over n cos what? Cos n over theta plus what? I sine what? Sine theta. Sorry, I was meant to say theta over n. Please, that n should be down, and theta over n. So this is just what the Moivre's theorem is explaining. But then you can have, there is a particular question for those of you that watch the video from the very beginning. There's a particular question that you can be asked to multiply two complex number. Let's say you are asked to multiply z1 z2, okay. In that case, and maybe both of them has n, this will now be r1n multiplied by r2n, okay, into cos. Then in this case now you have what? You're having two thetas, okay. You'll be having what? Two thetas. So you have what? Theta 1 plus what? Theta 2. And make sure you multiply them by n plus I sine what? Sine the same thing, theta 1 plus what? Plus theta 2. And make sure you multiply by n. For the division, anywhere you see plus, you make it what? Minus, okay. And that means you have to divide r1 to the power of n over r2 to the power of n. If it's 1 over n, you put your 1 over n everywhere. But then don't forget, sometimes theta, they can just decide to add 2 pi what? K, where k is equals to 0 plus or minus 1 plus or minus what? 2. What that simply means, this place you have theta, all the place you have theta, you have just add plus 2 pi. Then it now depends on what they told you your k was supposed to be. But most of the times your k can be 1. Okay, if it is 1, this will be what? Theta plus what? 2 what? Pi. Okay, now moving to other questions. Now this question is very important. We'll still come back to this one. There's a slight mistake, okay, in this one, because what I'm looking at is, I was actually looking forward to getting what? The value of n, but this is what is going to be. Now in conclusion, let's just conclude this at once. This is going to be minus 40. This is going to be minus 40. Okay, don't worry, we'll come back to this. We'll solve this at the end of this. Just pay attention to the end, okay. I just want us to make sure that we are getting all these things right. Okay, now tell whether the following is convergent or what? Divergent. I just want to go straight to the point. And also with the test that is involved. Now anytime you see this, the test that is involved in this is what? It's called the Ambert ratio test, okay. It's called the Ambert, okay. Is it Allenbert or what? Yes, Allenbert what? Ratio test, okay. The Allenbert ratio what? Test. Now and in this case, whenever you do this, it should always what? Converge, okay. It should what? Always what? Converge. Now for this one, if you enter, you see this, anytime you see what? Factorial, just know that, especially in this our CA, for those of you offering this course, Math 206, you are still going to use the same test, the ratio what? The ratio test, okay. And it should also what? Converge. If you see this, and if you see something that has to do with what? uh m and m, it's as if the ratio of something to the other. Now this actually converges at this, so this is what? This is going to what? Converge. Now if you ask me to explain why, it's because, and the test which you are going to be doing for this particular one is not the ratio test, okay. The test which you are going to be doing for this particular one is going to be the what? The okay, we'll come back to this one. Let's come to this one. For this one, it's almost something relating to this. You can see that it's as if you are doing the ratio of n to n. So this is going to be the ratio what? The ratio test, right? And it should also what? Converge. This one is going to even converge what? This one is going to converge uh this one is going to converge completely. Completely, yes. Exactly. Because at the end of the day, you have something like equals to 0. We are not proving it though. Now this one should converge. Now what test are you going to use? This one you're going to use a test known as telescoping. Telescoping. Telescoping, right? Or some people can call it, instead of call it as you can call it telescoping, or there's another word given to it. Okay. Okay, that's by the way, shall let's continue. Telescoping test. Okay, telescoping what? Test. where you have, or partial fraction. You're going to do your partial what? Partial fraction test. Okay, partial fraction what? Test. Now moving on, they said that a series this is said to be convergent. I just wrote this out because this video is getting too long. So a series this, please hold it, please, is said to be convergent if its sequence is of partial sum. Now you can see that I want to explain this now. This thing you are seeing is what is equivalent to what you are seeing there. Is what is convergent if its sum of partial, if its sequence of partial sum is convergent. So the sequence of partial sum of this is actually convergent, thereby ending at what? 3/4. Whatever you do, it will still be 3/4 that you will get by the time you sum everything together. So this was exactly what this is talking about. So, and at the end of the day, you will get the total sum to be what? To be 1. Okay, you get the total sum to be 1, meaning the total sum is still within the range. That means it is not greater than 1. It's end at 1, because as n tends towards infinity. Now look at the series converging by telescoping series. That's exactly what I was explaining here. Okay, I just wrote this out to explain. And this is how you do your partial what? Your partial fraction. This you are seeing now, same thing as this. Okay, exactly. So that is it. Now let's look at this. Now they gave us this, so we're going to write what happens to it. Okay, is it going to converge or diverge, and what test actually was used. Now anytime you see this, pay attention. Anytime you see this that you're seeing, when you're seeing this, what should come to your mind is that this should what? Should it depends on what the power actually is going to be. Okay, whenever you are seeing this, it depends on what the power. So this is going to be p series test. So this is going to be p series. Anytime you see the denominator to the power, it's just going to be what? P series test, right? So, and every time, most times, p series test will either converge or diverge depending on one condition. If the n here, which is the power, p stands for power, so this can be known as power, but because I wrote a subscript n as a sequence, so since this n here, anytime that this n, let me use this to explain. Whenever this n, which is, you should look at it as p, whenever it is what? Whenever it is greater than 1, it should converge. Okay, and whenever it is what? Less than what? 1, it should what? Diverge. But the fact that we have some powers here, and then over this should what? Converge. Okay, this should what? Converge. Now let's move to the next one. Okay, so moving on, we now have if you look at this one now that we are seeing here, is they gave us a question. They told us, for this particular, they told us that we should find does it converge or diverge, and what test exactly. Okay, does it converge or diverge, and what test what exactly. So looking at this now, what should come to your mind is, what do you have here? 1/3, right? So since you have 1/3, it is actually less than or equal to 1, so it should what? Diverge. Anytime, and looking at this from what I've already said, this is the p series what? Test. Okay, this is the p series what? Test. Okay, so in that case, we have been able to do this now. So let's move to the next one. Now in summary, it will converge when the p is greater than 1, and it will diverge when it is what? Less than or equal to what? 1. Have it at the back of your mind. Now when p is equals to 1, the series becomes what? Harmonic. Yes, if you continue to increase by 1, 1, 1, it is what? Harmonic. Okay, when it is 1, it is harmonic. Let's say 1 over 1, 1/2, 1/3, 1. So that's an harmonic what? Harmonic. 1/1 plus 1/2, that's harmonic series. Okay, 1/1 plus 1/2 plus 1/3 plus 1/, so that is harmonic series. Okay, so with that being said, let's continue. Now in this case, look at the next question, please. I don't know if you guys can see this question. This is it here, and they say, is this that you're seeing a monotone sequence? What is the monotone sequence? A monotone sequence is actually a sequence that what? That how will I put it? It's actually a sequence that it will continue to follow this pattern that I wrote here, or it will continue to follow a particular pattern. Let's say it is, we have, that's why we have monotone decreasing and monotone increasing. I think I've explained that earlier. For those of you that watched the video from the beginning, that's why you have to follow this thing chronologically. So for monotone sequence, it will be what? It's either it is what, monotone increasing or monotone what, decreasing. In this case now, it is actually what, or it is when it's going to be either increasing as a result of, it will continue to remain the way it is, or it will be increasing or what, decreasing by what, by a particular factor. Okay, so this is a monotone sequence, because by the time you substitute what, by the time you substitute 1 here, you're going to be getting, if you substitute, no matter be the number you're going to substitute here, you keep getting what, -1 -1 -1. So this is what a monotone what, sequence. Okay, now take note of the following, very very important. A sequence is said to be what, convergent. What, emphasis on what, on the what, on the convergence, if there is a real number L such that for any given E is what, part of what, part of that sequence, it must be greater than what, 0. There is no, there is what, there is every what, element of that particular what, sequence to be what, to be what, and a natural number. Now what this is trying to say, that for a natural number, all the numbers, natural number, that is all positive numbers literally, um it is going to be convergent if you get what, a real what, number, like that is what, greater than 0. Any number greater than 0, provided it's greater than 0, it is what, going to be convergent. What do I mean by that? For all what, for all value, it must be what, it must be greater than or equal to n natural number. Natural numbers are numbers 1, 2, 3, 4, 5. So the number must be greater than 0. So you must get 1, 2, 3, 4, 5. You must get like above. You must what, get above. Especially you must be getting above 1. Especially you must be getting above 1, because so most times if there are some kind of test that you are going to get 1, you are still going to be emphasize on it, whether it is convergent or divergent. So it must be greater than what, 1. That is it. Or greater than what, real, for a real number, it must be what, for, even if it's going to be a real number, it must be an element of what, of a natural number, it must be greater than what, 1. That's what this is trying to say. So let me read it again. Sequence, this is said to be what, convergent if there is what, a real number L such that for any given what, E, this is epsilon, which is showing that constituent or part of that number, it must be greater than 0, very important, and what, that element must be what, a natural number, and for all value that you must get, it must be what, greater than what, that number, that must be greater than 1 and above. Okay, so now hence if a sequence, this is another thing you must take note of. Okay, you must what, take note of. Now if a sequence is not convergent, then it is what, divergent. Okay, remember, if L is going to be 1, you are still going to check, you're going to still run another test, because in that case it is not decided yet. So but if it is what, if it's greater than 1, then fine, it is convergent. Then it is what, if it is less than what, or equal to, sorry, if it is what, if it's just greater, if it's just going, if it does not have uh what do I, how do I put it, if it is just maybe increasing to the positive or increasing to the negative, then, or let's say if it is less than, if it is less than, okay, let's put it this way, if it is not convergent, thereby greater, being greater than 1 and having a particular value as it is greater than 1, this one, it is, let me just put it this way, if it is what, if L is greater than, let me not put 1, do you know why it is so? Then it is divergent. If it is, if it continues to what, increase, when they say something is divergent, the thing continues to what, increase, maybe to the negative or to the positive, right? It just continues to increase, right? Since it continues to increase to the negative or not positive without having a particular or a definite number, then it is what, divergent. That's exactly what it means. So in this case now, let's look at the next thing. They say a sequence, this is a real number, of a real number is said to be bounded if, now anytime you see this, do you know what should come to your mind? This simply means such that we have it there exists what, there exists a particular member of what, M, or there exists what, M. This thing means there exists. That's exactly what this thing means. So said to be bounded if there exists M to be greater than what, 0, such that you have an absolute value of what, A subscript n, that is a sequence to be what, less than or equal to what, m. For all value of n, it must be greater than or equal to 1. What this is trying to say is any sequence at all, so that it is what, of a real number, that sequence must contain what, the constituent of that sequence must be what, a real number. In that case, it's said to be bounded. When I mean bounded, bounded means, there's a boundary. That's what bounded, right? It is said to be what, bounded. This is a definition for what, bounded. If what, if there exists what, the what, that m to be what, greater than 0, it must be greater than 0. That is just the condition, such that the absolute value of that sequence or that particular sequence must be less than or equal to what, m. The absolute value, okay, the absolute value must be what, when something is greater than 0, then it is what, definitely you are going to be taking the absolute value, meaning it is all going to be what, positive starting from 1. In conclusion, what this is trying to say is all of these are going to be natural what, numbers. All of them are going to be what, natural number. That is what he's trying to say. Okay, especially when you have been given condition, when it is n is what, greater than or equal to what, 1. Okay, now by comparison test, there's a particular test known as comparison test. I've not talked about that test. So for comparison test, it is when you are comparing between the numerator and denominator, comparing between two what, two function, okay, or two sequence, right? So for comparison test, if you compare between them, it's either going to be divergence or what, convergence. Okay, for that particular sequence, it must not be equals to 0. Yes. Now what it simply means is this thing I'm trying to say, whatever you are going to get must be equal to what, if it's 1, it is neither what, convergence nor divergence. So you are still going to run what, you are going to run a comparison test, thereby telling yourself to now compare and know what exactly is going to be, because it will not be what, equals to 0 in that case. And when something is not equals to 0, it is neither what, convergent nor what, divergent. But if it is equal to 0, you can be able to use that phenomenon to now determine if it is what, divergent or convergent. So you can be able to know if it is either divergent or convergent by using comparison test. So comparison test is not, it is not specific to being either convergent or what, divergence. But most times ratio tests can most times used to be what, convergent. Telescoping, convergent. There are some that are just what, that are just specific to what they are meant to be. Okay, with that being said, let's solve the final set of questions now. The final set of questions. Okay, let's solve the final set of questions now. 20i. Now look at this. They said we are to master this. This is a condition. Master your infimum and what, supremum. Now this is where you should know your infimum and supremum. Very important for your infimum and what, supremum. Now a is what, is the infimum of a set of a, this means is set. So this is what, the constituent of that set, which is the element of that what, of that set. Am I making sense? So in that case, if there are two conditions, if that what, element is less than or equal to a, meaning that element must be inside, you must be seeing that element. For instance, let's say what it simply means, let's say you have set of what, 1, 2, 3. The infimum is trying to tell you the lowest, so it must be there. Even if you have 1, 2, 3, this bracket and this bracket are two different. This one means one is excluded. In fact, 1, 2, 3 are excluded, or they are not included. That's exactly what it means. Okay, 1 is excluded, 3 is excluded. So the infimum is still going to be 1, despite the fact that you are trying to tell yourself that 1 is not in this what, in this set or in this range. The same thing here. So that lowest value, so that lowest value that we are seeing is what, our infimum. So the lowest value is going to be less than or equal to the element that we see there. Okay, now another thing again is that it must be what, it must be within that what, you must be seeing it must be within that what, that set. Okay, it must be within that set. That's exactly what this is trying to say. A must be less or equal to this, which is what, less than what, a plus e. This is it. It's going to be one of the elements there. It's going to be one of the elements of that what, of that set. Now for a set A, for that of supremum, for a set A, first of all, that set must be what, must be an element, must be less than or equal to what, Sorry, this is set of what? This you see is set of what? Is set of what is it called? Is set of, let's look at this very well. B is a what? Is the supremum, right? Now this B now is the supremum. Remember what I told you here is what is the constituent of that set. This A must be either greater than the A. This is the A as in the set must be what? Less than or equal to this. It must be less. That's the smallest. Now this now is what we are looking at. It must be greater than, looking at it from here, it is greater than what? The set. Remember the same thing you are seeing here is the same thing you are seeing here. This must be what? Must be this you are seeing here. This is it. Okay. Now, that supremum value is just like having, let me just explain it here. Let's say you have one, two, three. This is your what? Your supremum. Even if you have one, two, three, this is your what? Your supremum. It is what the greatest value that you are seeing there. It's as simple as that. The greatest value that is likely to come up in that set or what? Or that sequence. Now, that is all. Now, for this one now, it's, here we said it's going to be plus what? Plus E. This E is trying to say that the constituent, right? This is epsilon, which is part of what? Part of that set. So this now minus what? Part of that set. So it's going to be what? This is going to be, this minus part of that set is going to be less than what? The element that is in that set. So just take note of this. Okay. Now, in this case, we say that our supremum, to cut the long story short, is the greatest value that you're seeing in that set. Okay, the greatest value you're seeing, regardless of whatever be the word, the kind of bracket, whether it is not, it is less than or equal to the greatest what? Upper bound or highest bound. Now, let's look at more things about supremum and infimum. Infimum of A in this, let us find it. From what we have discussed so far here, the infimum of A is -4. Simple. The supremum of this same thing we are looking at is what? 9. Infimum, supremum, and case close, right? So let's look at this. The infimum and supremum of this. Now, this is a set x such that what? We have -8 is less than what? X, and is less than what? This. You can see that they are saying less. They are mentioning less, but then you should still consider them as the supremum, infimum, and what? Supremum. The infimum, respectively, and supremum. The infimum is what? Minus what? 8. As simple as that. Why the word supremum is what? Is infinity. That is it, and you have gotten your answer. Positive infinity. Now, lastly, the last question we have here, the infimum and what? Before we move to the next one, the infimum and supremum of B of 1/2. If you see this is decreasing, and when it decreases, it will get to what? 0. Now, the infimum is that smallest value, which is what? 0. The supremum, remember, we're following it respectively. Infimum before supremum. The supremum is what? Is 1, because that's the highest value that we have here. That's all. Now, moving on. Take note that a complex valued function f of z is said to be what? Analytic at each point. Okay, if it is what? Differentiable at each what? Sorry, if it is differentiable not only what? At what? Z, but also at some neighboring what? From some neighborhood of z. What this simply means is there are two things when it comes to an analytic function, or a function that is meant to be analytic. Or first of all, a complex function, it has what? Real part and imaginary part. What this is trying to say, so if you are looking for, we have actually done something like this. I've explained something for those of you that watch this video from the beginning. That's why it's good to watch video from the beginning. So if you have not watched from the beginning and you skip to this place, go back. And mind you, if you have not subscribed to this channel, do well to subscribe to this channel, as you get more updates. Okay, now in this case, we have what? For a complex number, we have the real part and the imaginary part. Okay, let me write something here. We have function, a complex function of x plus iy, the real part and the imaginary part, right? So for the real part, now if you are considering only the each point, okay, so if you are considering the only the differentiable aspect and not considering the other part, it's not like considering one part and not considering the other part. So you have to consider both parts. Okay, you have to consider what? Both what? Parts. So that is what this is trying to say. So a complex valued function is said to be analytic at each point z subscript 0 if it is differentiable not only at that z subscript 0 but also at some neighborhood of z. the neighborhood of z is what? The other part. Now, for instance, if you have a complex function, this, it can never be equal to this. Yes, it can never be equal to this. The reason is because um at z equals to 0, yes, it is it is perfect. Like it's going to work because you're going to use your Laplace equation. I've discussed that for those of you that watched this video from the beginning. Now, but at no other point it is not going to work. So it is not what? Analytic. It is not what? Analytic, because it is only the real part. Whenever you find this, it's only the real part that will be visible. The imaginary part will not be visible. So hence it's not what? Analytic. Now, look at this. This is another thing you need to take note. These are all what you need to take notes. Please pay attention. Only monotone sequence that are bounded that will converge. Okay. How will I put it? Let me say it this way. Only monotone sequences that are bounded converges. Okay. They are the only one that are what? Convergent. It's only the monotone sequence that are bounded that will what? Converge. Please add that at the back of your mind. They ask you that what kind of monotone sequence would converge. Is only those ones that are what? Bounded. For instance, if you have something like this, they tell you that this is this. Whatever you are putting is what you are getting. So that means it is bounded. Bounded means it is maintaining what? It is maintaining a definite what? A definite value. So it is bounded. When they say something is bounded, let's say, I think I discussed that in one of the okay, I discussed that here. Let me explain it again. So this is it. So this now is a monitor sequence that is what? Bounded, because you can see that we are still having minus one, minus one, minus. So this is like the boundary. So it's bounded to this. So that is it. Okay. And it doesn't what? It doesn't diverge, because diverging means it will continue to what? Increase. This one is not increasing. It is what? It is the way it is. Now a vector is said to be. Now I'm not going to do questions on vector because I don't think questions on vector will come out for this test. Okay. So I don't think questions on vector will come out in this test. But then if it does, I'm still going to make a video subsequently. Now, a vector v is said to be solenoidal if its divergence is 0. Okay. Now the condition, the divergence must be what? 0. And not just what? A constant. Now it's not just getting a constant. That constant you must get is going to be what? 0. That's the condition. So a vector is said to be what? Divergence if what? It is 0. So the opposite of a vector being divergence, that means what they are trying to say, it is going to be what? It's going to be irrotational. Irrotational in this case. Okay. It is going to be what? Irrotational. Now, for it to be irrotational, that means it is what? Divergence. Now, there's a particular expression that we normally use to depict irrotational. Okay, we said this is equals to 0. So it must be what? Equals to 0, and that proves that it is what? Irrotational. So let's move forward. So let Q denote that the set of rational numbers. If B is such that we have an element of what? Of Q. Come in. Who is that? You are distracting me. Oh. So such that we have an element of what? X is less than or equal to root 2. First of all, if you look at root 2, be careful. So if you look at root 2, root 2 is not root 2 is not what? Is not a rational number. It's irrational. Yes. Yes, root 2 is not what? A rational number. Yes, exactly. So from the look of things, if you ask me to find what is the max of B, there's something called minimum and maximum. Minimum of what? And maximum, right? Exactly. So minimum and maximum. Minimum is the minimum value that is included in that set. So minimum is what? Included. It is what? Included in that set. Why maximum is also what? Is the highest. This one is the lowest included value. Why maximum, right, is what? Is the highest included what? Value. Okay. So maximum is what? Is the highest value that is included in that set. Highest included what? Value. It's not like the supremum and what? like it's not like the supremum and the what infimum, that it must not necessarily be what included or what or excluded. Okay, so let's take note of that. Now, if that's the case, and we say that this is not what is not an irrational what irrational, instead an irrational, so the answer to this is going to be, it is not what it is not, the max is not going to be what equals to root what root 2, as simple as that. Because you can see that they told us that it is what included. This thing means that it is less than or what or equal to, meaning it is root 2 is actually included in this set. But the fact that it is not what irrational, look at the condition, they told us that it must be what irrational number. So that is it. Now they said that a function of z is said to be entire if it is what analytic in the whole finite. So this is the what this is what I just said here. In summary, it is said to be what entire. Entire means, you know that entirely for what for z we have what real part and imaginary part, right? For z we have the real part and the what the imaginary part from this expression I showed here. But then uh if it does not meet the condition of entirety, that means it is not analytic. Okay, it is not what analytic. So in that case, let's move on. So for a function of z to be what entire, if it is analytic, sorry, it is going to be entire if it is analytic, and being analytic means it must what have both the what both the the real part and the what imaginary part. Okay, now the next thing I want us to take note of all these things I'm about to say. Cause I, please master this. Although this thing was done with respect to hyperbola, I will still explain this thing in another video, but for the case of the for the essence of this test, you just have to take note of this. So cos I is e to the power of 1, that is natural e plus e to the power of minus 1 over 2. Now for sine I, what do you think is the difference? Plus will become minus. For sine I, it will become what? Minus, right? Then always also have it at the back of mind, because I don't know what question with this will be. Root AB is less than or equal to half of what? In fact, it's even equal to, not that it is less than, it's even what equal to. But the fact that it's less than or equal to is considerable, is either it is less or it is equal. So it was less than or equal to half of what? AB, right? It is less than or equal to what? The half of what? AB. Okay, when it is found. Now finally for a bonus what? A bonus question, let us look at this. Okay, I'm rounding up very soon. For a bonus question, let us look at this. Please, if you haven't subscribed to this channel, do well to subscribe to this channel, and do not forget to share this video. Now let's see, take note of this. The function of this is not analytic. Yes. Now I've been mentioning this since, like I've said it like about 4 times in this video. So let's see what absolute value of z squared actually mean. Normally z is what? X plus what? Iy. So this is an analytic function. Yes, and they want us to actually say that this is this expression, and this thing now has what? Real part. It has what? Real part as well as imaginary part. So if we expand this and we get real part and imaginary part, that means it is analytic. Let's see, this is actually what? X squared plus y squared, then minus 3. Did you see any imaginary part? No, because of no what? Imaginary what? Imaginary what? Part, right? So because of the fact that there's no imaginary part, that is what makes it what? That's what makes it not analytic. If there was imaginary part now from this thing I did now, so this thing is actually this expression, then you now add what? Minus 3. Okay, so this thing is this expression. Please don't take it wrongly. Now let's look at this. Now look at this thing. There's a particular test series that is called alternating. An alternating series is when you're having, let's say you have minus, before you have plus. Minus 1 plus 1 plus 1 over, let's say 1 over something. It will be minus of something and plus of something, right? Now that is what we call an alternating what? Alternating series test. And this is an example of such, because if you put 1 here, minus 1 to the power of 1, anything to the power of 1 is still the same thing, over 1 is still the same thing. If you put 2 here, this will now become plus, and this will now become over 2. So what you will now be getting here is going to be, first of all, you get minus 1, The next thing, you now get plus 1 over what? Since it's a series, I'll be adding, because series is like addition, addition. Sequence is like something like 1, 2, 3. So now this will be what? Over what? 2. Then minus. The next one will now be minus power of 1 over what? 3. So you see that, you see the way the thing is going, alternating, minus plus, minus plus, minus plus, minus plus. Now with that being said, let's look at this one. So we're almost gradually getting to the end of this video. Now they say this absolute value of what? Of this, right? Now the absolute value of this is something as this expression, and it diverges by what? By a particular test. Let's know the test. Now that we have 1 over this, the test that is involved in this case is simply uh mm, the test that is actually involved in this case. We have different tests. We have P series tests. We have what again? We have P series tests. We have comparison tests, and so on and so forth, right? So if that's the case, what the test that is actually involved in the case of this is going to be what? A comparison test. Okay, it's going to be what? A comparison test. And by the time you have done comparison test, you will now get that this thing is what? Going to diverge. Okay, so the test that is involved in this case is supposed to be what? A comparison test. Now or let's look at it very well so that we will not make mistake. So we have 1 over n. So if you put 1 here, it becomes 1, right? So if we put 2 here, it becomes 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on and so forth. So this particular test, looking at it, we can see that this test is not going to be comparison test. Sorry, I was meant to say this test depends on uh, if we find the absolute value of this. Okay, sorry, it's going to be comparison test. Yes, it should be what? Comparison what? Test. So comparison comparison test. Why? Because if you see, this thing was resolved to be this, and when it was resolved to be this, as I thought, we have two things, two factors here. We have first factor up and we have one factor down, and it's going to be the absolute value, right? But looking at this now, aside from that, okay, yes, let's continue. So let's solve this. Okay, let's solve this. I to the power of I just showed this because I don't want to waste time in this video. Now I to the power of I, this I to the power of I can be expressed as e to the power of I log I. Yes, exactly. So I to the power of I, have it at the back of my mind that this is an expression of I to the power of I. Now you know that I, you still have your I, right? Definitely you still have your I. Then this your I now, and then you have log I. Actually log I, from this expression that I told you, log I is this. So if log I is this expression that we are seeing here, that's log of 1, because you're going to find, it's just like doing the what is it called, what I did. I've done 2 of those questions now, the principal value. So once you do the principal value, this is exactly what you're going to get. And log 1 is 0, right? So this is 0, this is what you have. So if you have this, now, that means this is the only thing you have. I times I. Since log 1, you know that you are going to replace everything here. You put it here, right? If you put it here, if you put all of these things there, log 1 is 0. So this is the only thing you have, I and this. And then the reason we came about this minus, because this I now will now multiply by this I. And when the I and the I multiply, we get minus 1. So that's why it is minus of what you have here. Now, whatever question you have, drop it in the comments. I am ready to answer all your questions. Now, what is the principal value? Sorry that I'm being too fast, but I just want to make sure that this video is not too long, and I want to make sure that we are actually getting this the right way. So how do we get this done? To get the principal arguments, first thing first, we need to find our what? Our modulus. So I'm going to be solving question 5 here. If there's any other space, I will solve what? I'm going to be solving question 5 here. If there's any other space, I will solve question 6. So now we have 1 minus I root 3 over what? 1 plus I what? Root 3. So the first thing to always do is to rationalize the conjugate by the conjugate of the denominator. So as you have 1 plus I here, you have 1 minus I root 3. Okay? And over 1 minus I what? Root 3. Right? So if we do this, to get this done fast, for those of you that know how to expand very fast, And I told you that anytime you have the same thing, but the difference is plus and minus. First to first, 1 times 1 is 1. Plus times minus is what? Minus, right? I times I is what? We've said it before that it's minus 1, so this will now become plus 1. Root 3 is what? 3, right? So to get this now, for the up one, we have 1 times 1, 1. Okay, so anytime you are given something in this form, you may see another question in this form. Please always do this. Always do this, because of time I cannot be able to do all these all of them. So because of I don't want this video to be too long. Now always do this. Anytime you see something over something, you are seeing two complex number one over the other. Always do this. Okay, and then change the plus to what? Minus, and rationalize. Okay, why you are doing that? So that you can make it easy and remove some kind of discontinuity in that stuff. But this time around, we're not looking at continuity in this case, but rationalization. So let's do this. First to first as last to last. Close. First to first as last to last. Let's do that here. First to first, 1 times 1 is 1. Last to last, minus times minus is plus. But due to I, since I was supposed to write plus, but I'll write minus. So root 3 is 3. So I'm getting this gradually. So to get what I'll write here, now this is the real part. The imaginary part is what I'm left with. So to get the imaginary part, take this 1 times, this one does not have imaginary. This one is just real part here, that is imaginary part here. That will be minus what? I what? Root 3, right? Imaginary part here with real part here, that's another word. That will be another minus what? I what? Root 3. And in conclusion, you have what? 1 minus 3 is what? Minus 2. Everything down here is over 4. Then here we now have minus I root 3, minus I root 3. That will be minus 2 what? I root 3. So if you split this now, you separately, you have minus 2 over what? This 4, right? That will give you minus 1 over 2, right? In that case, the other one, you have minus 2. This will cancel this, so you equally have minus I what? Root 3 over what? 2. So this is it. So this is the real part. This is the what? Imaginary part. With that being said, remember what they asked us to find: argument. So to find the arguments now, remember I told you the tan inverse of what? The imaginary part first, which is what? Minus what? Root 3 over 2 all over the real part, which is minus 1 over 2. Right? So with this being said, this is now going to be the tan inverse of minus. To cancel minus, definitely 2 we cancel 2 here. So what you have here is root 3 over 1, right? And this is actually 60 degrees. Now if you see 60 degrees in the option, fine, that's the correct answer. But in terms of pi, if we want to write this is going to be 60 degrees multiplied by pi over 180 degrees. This and this, definitely this is going to be pi over what? 3. And that's our answer. Now lastly, so this one, theta is what? Pi over what? 3. Now I want to solve this one here because I don't have space any longer. So solution to number 6, right? Please pay attention. We are rounding up now. So what we just have to find here, since they asked us to find the Euler form, and the Euler form is going to be z is equal to r e theta what? I, right? So z is equal to what? R e theta what? I. That's the Euler form. So we need to find our r and our theta. So those are the two things we'll find. So to find our r from here, remember, it's going to be the square root of the squares of what you have here. So let's just do it for 2 square is what? 4. For those of you that follow me from beginning, we already know this thing, plus this thing all squared. So minus 2 squared, you would say is 4 times, these things are combined, so you must do them together. Root 3 squared, square will cancel what? Square root, you have 3, right? So in conclusion, our r is going to be square root of 4 plus what? 12, which is square root of 16, which is what? 4, right? So our r, now I've gotten my r, and I will say that my r is what? 4. So what's my theta? My theta is what? Is remember always what is going to be the tan inverse of what? The imaginary part, which is minus 2 root 3 over what? The real part, which is what? 2. From here 2 we cancel 2, right? Hope we are getting it. And our theta is going to be tan inverse of what? Root 3 over nothing, definitely 1. Sorry, not nothing, 1. So we have done this before. So we can see that vividly this is what? Still 60 degrees. And theta is going to still be pi over 3, as I said earlier. So just for you to combine everything together. So this I had issue with my phone. So as you have gotten the argument, we've already gotten the argument to be sorry, the modulus to be 4, and then we've gotten an argument. We say that it's the same thing. Okay, from our expression here. From our expression here, we say that the argument is the same thing. So just for you to substitute everything, so your pi, you write 4, you write your e, then this theta is where your argument is, and of course you said that your argument was what? Pi over what? 3, right? So that means you put your what? Your pi over 3, then I, and this is your answer. So that is how to actually get it. But then sometimes it depends on the argument that you asked to get. Let me quickly briefing you guys on argument. There's principal argument and there's what? Ordinary argument, right? So there's ordinary argument. Now the principal argument is within the range of minus pi to what? To pi. Okay, so whatever you're doing, whenever you want to achieve your principal argument, you're going to be using the range of minus pi to pi. What that simply means is, depending on the quadrant that you're actually working on, okay, that's where you get your principal argument. But this is going to be a video for another day. But if you're asked to find your principal argument, or in fact, let me even talk about it. Let me get another paper. So this video is becoming too long, but then no problem. So this is another paper here. This is your quadrant, first, second, third. So whatever be the argument you get here, emphasis on principal argument, because ordinary argument, for ordinary argument, whatever you get, you just need to add 2 pi what? 2 pi k, where k can be 0. If it's 0, then it's still pi. If it is 1, plus or minus 1, or plus or minus or 2. So but then for the principal argument, this is your first quadrant. Okay, so this is your first quadrant. For your second quadrant, so this is still going to be same thing as the principal argument. But then for your second quadrant, if you get a value for what? Theta, you must subtract it from pi. For the third quadrant, if you get a value for theta, you must add pi to it. Okay, then for the last quadrant, if you get a value for theta, all you just have to do is just what? You insert minus to it. So this is your fourth quadrant. Okay, so that is all for now.